Welcome to Integration Part 1. For our first look at this, we're going to look at the definite integral to be defined to be the area of the region between the curve and the x-axis from two values, from x equals a to x equals b. This is a very simplified version, but it'll give us just a basic start. So the integral is that S-looking shape from a to b of a function, so a graph, dx means it's with respect to x. So we're going to look at two methods. We're going to calculate the area of the shape that's formed between the curve and the x-axis, and then we're going to find the primitive, which is what we've done in our last lesson, so anti-differentiation, and we're going to solve. So once we found the primitive, we'll sub in the b value minus substituting in the a value. So here's our two examples. We're going to evaluate the integral from 0 to 6 of x with respect to x, so dx, and the integral from 2 to 4 of 2x minus 3 dx. So the first one, the integral from 0 to 6 of x dx. So the graph of y equals x is just a straight line. And if we're looking from 0 to 6, we form a triangle with the x-axis. So remember, we're going to look at our two methods. So our first method is, we're just going to find the area of the shape that's formed. So it was a triangle, and the area of a triangle is half times the base times the height. The base was 6, the height was 6. So when you substitute that in, you get 18 is the integral from 0 to 6 of x. Using our anti-differentiation or using our primitive, so we raise the power, divide by the new power. So the x becomes a half x squared between 0 and 6. So we substitute in the 6 minus the substitution in of the 0. So a half times 6 squared minus a half times 0 squared. And when you put that on your calculator, you get 18. The second one was 2x minus 3 between 2 and 4. So you can see a trapezium is formed, and the graph of 2x minus 3, that would be a straight line. So the trapezium has a width of 2 from 2 to 4. The first parallel side has a height of 1. The second parallel side has a height of 5. So we can use two methods. So we can use method 1, which was finding the area of the shape formed, so the trapezium with the x-axis. So the area is a half times your height times the sum of the two parallel sides. So that's a half times the height between the two parallel sides was 2 plus 1 plus 5, which is 6. If we integrate, so using the primitive, between 2 and 4, so the integral of 2x is raise your power divided by your new power, that's x squared. And if we integrate 3, we get 3x. Substituting in 4 minus the substitution in of 2 is 4 squared minus 3 times 4 minus 2 squared minus 3 times 2. That's 4 minus 2, which turns out to be 6. So both methods get the same solution. Thank you.